So we are looking at the review for the performance activity. Okay. I am not going to do every single one of these, but I'm going to try to show the answers to all of the ones that I don't do. So we right now are looking at dilating by a factor of -2. So the first thing I'm going to do is use the centimeter side of my ruler, and I'm measuring and drawing a straight line from A to B. I get 3.6. From A to C, I'm drawing a line and measuring, and I get 2. And then from A to D, you can see that I'm drawing a line and measuring, and I get 4. Okay? Now I need to multiply them by 2. So my A to B is 3.6, and my A to B image needs to be, after I dilate it, twice as big. So it should be 7.2. A to C is 2, so it should be, my new A to C should be 4. A to D, I have 4. My new one should be 8. Okay? Now remember, it's negative, so it's down and to the left. And I am measuring it from A. So from A, I need to have 7.2. So this is my new B way down here. That's 7.2. My new C is 4. See how I line up the ruler so it's the same direction as the line is going? Okay, but it's down and to the left. This is my new C. And my new D, so I line it up so it's in the same direction, but it is 8 away. It's double as big. That's my new D. And then I'm going to connect D image to C image, C image to B image. This should be connected better, but, and D image to B image. So that is my new triangle. So it should look like this. Yes. Yes. Okay. I am not going to do the second one, but I will show you the answer. Now, if this was positive, remember this would be up and to the right. But since it's negative, it is down and to the left. Okay? All right. The second one is half as big. So I've got like A to B is 3.5. Half of that is 1.75. And these are all half as big. So see, my new triangle is right here. It's smaller. It's half as big. And it's positive, so that's why it's going the same direction. If it was negative, it would be down here. But since it's positive 1/2 or 0.5, it's right there. Got smaller. Questions about dilations? Yes?
Do you measure on A or do you measure on?
Always measure from A. Always measure from A.
Also, like, if you don't get what you call.
No, I'm more looking for that, like, it's twice as big or half the size. So, like, if you got, instead of 3.6, if you said 3.5, okay, that's fine with me. Okay. Now we are going to look at, we're going to construct a square, a rectangle, and a rhombus using our tools. So the first one that I'm going to do is with a compass. And on this paper right here, I am going to make a square with a compass. Okay? And then I'm going to make that square with a mirror and with patty paper, and then we'll move on. Okay? I think this is the most important one. This is the one that people tend to forget the most. Okay, whenever we're making any of these shapes, we always start with what? A straight line. Okay, so you'll already have your ruler. Doing it with a ruler seems to work pretty well. Okay, so my suggestion for when we're doing a square is for you actually to make the diagonals. The diagonals of a square are perpendicular, so they meet at 90 degrees, and they're equal. So the first thing we're going to do is cut this in half and make a perpendicular bisector. In order to do that, I take the pointy end and put it on one side, and I make sure that my compass is more than halfway. So it's not in the middle, it's more than halfway, and then I make a nice big arc. Once I do that, I move the pointy end to the other end of my segment, make a nice big arc. So you should have that kind of football-y shape right there. I took the pointy end of my compass, made it more than halfway, drew a big arc. Then switched it and put it at the other end point of my segment. Now, where those arcs intersect, that's where I'm going to draw a line right down the middle of them. Okay? Now, what we have perpendicular lines now. What we need is to make sure all of them are the same length. In order to do this, I am going to put the pointy end of my compass in the center. Make sure that the pencil end hits the line. And then I'm going to make a circle all the way around. That circle is guaranteeing that everything is the same point, right? Because the radius is all the same. Now, where this circle intersects each of these lines, that's where I'm going to connect. And I'm going to make a square. I put the pointy end right where the two lines intersect. And then I just made a circle around it. If you put these on here correctly, they do end up making 90 degrees. Mine aren't perfect. That one's better that way. And it does, if you turn it sideways, make us a square. Okay? So that is a square with a compass. Now we're going to do a square with a mirror. Okay? The first thing we always start with is a straight line. And we're going to do this almost the exact same way. We got a straight line. We know with a mirror what we do is we take it and we put it on our thing so it divides in half. Make sure that whatever hand you draw with, you make sure the beveled edge, the indent, is on that correct side. Then we make a line that goes straight up and down. We've now divided this in half. The problem is with a square, these sides have to be the same length. So I'm just going here and I'm making a mark. Oh gosh, it's very hard to do this through this. This is my dotted line here, kind of is showing where I'm putting this. I put this in both directions to kind of figure out where my line is to make sure everything's the same length. That little dotted line looking in both sides, make sure when I connect these that they're the same length so that I create a square. So that is a square with a mirror. Okay? I'm going to put it in highlighter. I put my mirror here and reflected my line. And then I put my mirror here and looked in both directions to make those dots. And then I've connected them. Okay, moving on to patty paper. Again, we're going to do this almost exactly the same way. We're going to draw a straight line. Okay. I'm going to fold this line in half so they overlap perfectly. Making that 90 degrees, okay? And then I am gonna fold it at an angle so that this side of this line goes on top of my folded side. So I'm making it so that it makes that like L-shaped, 90-degree L shape right there. And then I am going to make sure that I trace that. Tracing this L shape down. Do it on both sides of your paper. Gonna open it up and you'll have this big plus sign. And then you simply connect the endpoints again. Okay. Again, guys, if this is too fast, you can always watch my video, but you can always go back and watch the other videos too. All right, so to get full credit for this patty paper, you need this fold here and this fold here. Those two folds right there where it's folded in half and folded on a diagonal, and you'll get full credit. Okay, we're moving on to, what's next, rectangle? Okay, we're doing rectangle with a compass. This is the hardest one with a compass, I think, is the rectangle. All right, as always, we're doing a rectangle. As always, when we start any of these with a compass, we start with a what? Straight line. Okay, with a rectangle, it doesn't have to be straight in the middle, but we're going to make a perpendicular line. I'm not so worried about this being right in the middle, so I'm just going to make an arc right here. And then I'm going to move my pointy end, not to the other end point of the segment, but the other end point of the, where the arc and line intersect. And I'm going to draw a nice big arc. And then I'm going to make a line that goes straight up and down through those. And I know that this is now perpendicular. Now this is where it gets a little weird. I'm going to turn the whole thing sideways. And I am going to put where that intersects. I'm going to put an arc. And then where this intersects, I'm going to put an arc.
Wait.
So I put an arc where, here, I'll highlight it. I put my pointy end here, and then I put my pointy end here to make that arc. And then I'm going to draw a straight line where those two arcs intersect. Okay? And so this is now perpendicular, and the only thing I have to do now is connect these two parallel lines at the end. And right here in the middle, this is my rectangle. So what I'm looking for to get full credit for this is these two arc things right here. This one going this way, and then one going the opposite way. If you've got those and a shape that looks like a rectangle, you get full credit. All right, we're gonna do the mirror. I know this is fast, but we've got a lot to get through. Gonna look at the mirror. Okay, the mirror. We always start with a straight line. Good. Okay. Then I am going to set up the mirror so that when I look through it, they meet, but I don't need it to go right in the middle. I just need to make that perpendicular line. So I've set it up so I'm perpendicular. Okay, and I'm just going to do it at the other end as well. Just set it up so I have that perpendicular line. So I just want to make sure that you guys know I'm putting my mirror here, and then I put my mirror here to make those lines. And then I'm going to turn it this sideways, just so it's a little bit easier. You don't have to. And I'm going to make sure those line up right there. And I'm going to draw a line. And then I have my rectangle in the middle. Because this made it perpendicular, this made it perpendicular, these are perpendicular. So I made my rectangle. You cannot prove it's a square because you cannot prove all four sides are equal. I could have moved it down a little bit more if that helped make it look more like a rectangle. All right, we're moving on to patty paper. Okay, we always start with a straight line. Okay, we're gonna have to do some perpendicular lines here, right? So we're gonna take this and we're gonna fold this so these sides overlap. See how this little end point right here folds right on top of the bigger line? That's how we know it becomes perpendicular. Then we draw my line down, trace it. And then we're going to do the same thing with the other side. Make sure they overlap. Yep, just a little bit. So we've got this shape. So I'm going to take these two lines that go down here and fold them on top of themselves. And I have a rectangle in the middle. So for here I should have 3 folds. Each side is folded in and then this bottom part is folded up. So 3 folds and you got full credit for a rectangle. Okay, we're going to move on to a rhombus. Rhombus. Okay, we're going to do a rhombus with a compass, all right? So we always start with a straight line. Okay, we know with rhombuses, rhombi, that the diagonals are perpendicular. So we're going to start off almost the same as we did with a square. I'm going to take the pointy end at one end of my segment, make sure it's more than halfway, draw a nice big arc. Take the pointy end of my segment and make sure it's more than halfway. Don't change it at all, draw a big arc. And then I'm going to use my straight edge to make a line right down the middle. The only thing I'm going to do here is I'm going to measure the top and the bottom and make sure they're same length. So I put my pointy end right at the middle and I widen my compass, and then I'm just going to make sure that it's the same at the end. My end is a little bit longer, so I'm going to make a mark down there. And then I'm going to connect 1, 2, 3, 4. Those 4s together. Yeah, so I've kind of made a cross. Where a square is a plus sign, a rhombus is like a cross, except it's an even cross, where the top and bottom are the same length. Otherwise, you get a cut. Okay? So, rectangle is really the hardest to do with a compass. Rhombus and square, you're just using that compass once, twice. Okay? All right, now we're going to do it with a mirror. And we're going to do the same thing. We're going to start with a straight line. And then I'm going to use my mirror to cut it in half. I want it in half. That means this side overlaps this side perfectly. Okay? And then I'm going to draw a nice large line. So, again, I'm going to put in highlighter. This is where I put my mirror. And then I'm going to put my mirror right along this line, right here. And I'm going to make sure both these halves are the same length. It looks like this is a little bit longer. So I'm going to put that dot there to know where I connect them. Then I'm just going to take my straight edge and connect all of these endpoints. And I'll end up with, if I do this more accurately, then I'm going pretty fast right now. I end up with a rhombus. All right. Last one we're going to do with patty paper. I'm going to start with a what? Straight line. Okay? So I'm going to make a straight line. And then I'm going to fold that line in half. Okay? I'm going to draw just the top half, and I'm going to make sure it's pretty long. So I've made like an upside down T. So far, so good? Now I'm going to fold right along that T line. And then I'm going to trace it. And see how I don't have a plus sign, I have like kind of a cross. And now I'm just going to connect the endpoints, and we've got a rhombus. So I should just have two folds when I'm doing a rhombus right along those diagonal lines. Questions, comments, concerns about this? Again, I would rewatch this. You can go back and look at old ones too, but I've done a rhombus, square, and rectangle with a compass, mirror, and patty paper. All right. So we now are going to move to given a quadrilateral, that whole piece. I'm going to just show you what I have. Okay, so given quadrilateral HID, where H is 214, let me zoom in a little bit. I is 711, D is 11.1, and E is 6.4. You need to draw and make a sketch and label it. Name the four sides and their lengths. Find the slopes of the four sides. Find the lengths and slopes of the diagonals. Find the midpoint of the diagonals, and what shape is it and why. Okay? So here's just my little sketch. I didn't even use graph paper to do it. I just made a little sketch. Okay? On your performance task tomorrow, there'll be like a grid, so you can put it in. Okay? Or I'll give you graph paper. I used the distance formula to do these. You could totally use Pythagorean theorem. That's what a lot of you have done, where you go like, okay, how much is it up? How much is it over? And then use Pythagorean theorem to do it. But I got H to I was 5.83. So was E to D. I got ID is 10.77 and E to H is 10.77. So opposite sides are equal. I found that the slope to H to I was -3/5, so was ED. I found that the slope from I to D was 5 over -2, so was EH. So opposite slopes are parallel, but these are not opposite reciprocals, so they are not perpendicular. I found that the lengths from H to D were 15.81, and the slope was 13 over -9. The length from I to E was 7.07, and the slope was 7.1. So the diagonals are not equal, and they are not perpendicular. I found that the midpoints are the same. They were 6.5 and 7.5 for both HD and IE. And so my parallelogram, it is a parallelogram. Opposite sides are congruent and parallel. Diagonals are not congruent or perpendicular. They're not perpendicular. And diagonals are bisecting. So it has to be a parallelogram. Okay. Really good.
I have a couple of announcements. Today and tomorrow, seniors, this is a reminder that you need to place your orders for your cap and gown. Again, today and tomorrow, that will be happening in the East Concession Stand during all lunches.
Okay. I don't have time. So PL is 9.4, so is ALY. So is LA, and so is YP. They are all 9.4. So I have 4, please don't talk. I have 4 congruent sides. PA, slope is 1. LY, slope is 1. The diagonals are perpendicular, and they are, they have the same midpoint, but they are not congruent. One's 18.4 and one's 4.27. The slopes for PL and AY are both 5/8, and the slopes for LA and YP are 8/5. So they are not opposite. They're opposites. They're reciprocals, but they're not. One's not positive, one's not negative. So it is a rhombus, okay? Because all sides congruent, opposite sides parallel, diagonals are perpendicular and bisecting. So you should get that the next one is a rhombus. Okay, moving on. We are going to now look at this proof. Okay, everybody with me? We're on the proof. Okay, so remember we draw a line connecting to A. First, we're going to reflect over line 1. So A to line 1 is X. We reflect that over line 1. You can use a mirror or patty paper to do this as well. And we are X away for A prime. Now we have to take A prime all the way over line 1. Make sure you're taking A prime, not A. The distance between A and line 2, I hope you're listening instead of having a conversation and not being on your phone right now. You're actually paying attention. A to line 2 is Y. And we're going to take this whole thing over line 2. So we have Y, X, X, and here is A double prime. Okay? The angle between line 1 and line 2 is X plus Y. And the angle between A to A double prime is 2X plus 2Y. Okay? We've done that like half a bajillion times. Questions about this proof? Okay? Yes? Because the distance between here, so I'm looking between line 1 and line 2, X plus Y is in there. And then it asks me between A and A double prime. So here is A. Here is A double prime. So I want everything in that green section. So that's 2Y and 2X. Good, Cash? Okay. All right, let's do a translation. We're going to move all of these. Okay? 4 units to the right, 3 units down. So we're going to go 1, 2, 3, 4, 1, 2, 3. We're going to go over 1, 2, 3, 4, 1, 2, 3. We're going to move over 1, 2, 3, 4, 1, 2, 3. And we're going to move over 1, 2, 3, 4, 1, 2, 3. Okay, so our new points should be 3, -4, 0, -6, 7, -4, and 7, -8. Okay. The next one I'm not going to do, but it should look like this. We moved it 2 units to the right, 1 unit up. So my new spot should be -3, 2, -6, 6, and -6, 2. Any questions on translations before we move on? Okay, we're going to move to reflections. Okay, we're reflecting across x equals 2. So I go to the x-axis and I go over 2. A lot of people like to put y equals 2 instead of x equals 2. Remember, it crosses the x-axis. Okay, so now I'm just going to reflect this. This is 1 to the right. So it's going to go 1 to the left. 1 to the right. It's going to go 1 to the left. This is 1, 2, 3. So I'm going to go 1, 2, 3. This is 1, 2, 3, 4, 5, 6. So I'm going to go 1, 2, 3, 4, 5, 6. So here is my new, and it is, points are 1, -1, 5, -1, 8, -3, and 1, -5 are the new points. Okay? So I'm not going to do the second one, but I'm going to put the answers up here. I reflected across the y-axis. That's the y-axis right there. So my new point should be 1, 1, 4, 1, and 4, 5. They're equal distance from that y-axis. Questions about those? Okay, let's move on to our rotations then. We're going to perform a rotation of a counterclockwise 90 degrees about the origin. Okay? Counterclockwise is what? What is the formula? I go from x comma y to, I believe it's -yx. So I like to write it down. I like to write down the points instead. So instead of 3, -1, I'm going to be at 1, 3. So I'm going to be at, go over 1, up 3. No, that would not be a rotation of 90 degrees clockwise. It wouldn't, both of these wouldn't change. It's -yx. Okay? Instead of -1, -1, it becomes 1, -1. So I'm 1, -1. Instead of -4, -3, I'm 3, -4. 1, 2, 3, 1, 2, 3, 4. And instead of 3, -5, I'm 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. So here is my new one. Now, you do not have to do it this way. You could draw it and then move it, like I've seen people copy this on patty paper and then spin it. That's fine too. I find this way to be more accurate, but you guys can do it either way. So again, this went from x comma y to -yx. Okay? So I'm not going to do the next one, but I'm going to show you the answers. This was 270 counterclockwise, so it went from xy to y -x. So I went from -1, 1 to 1, 1, -4, 1 to 1, 4, and -4, 5 to 5, 4. So it went here, because it went counterclockwise. Questions? Okay, I went through this pretty fast, so where do you guys have questions? Where can I go back to? Do you want me to go back to, a dilation 1? Do you want me to do a compass or a mirror or a patty paper again? The proof? Go back to the proof? This one right here? Do you want me to just go over what I did again? Okay, so I'm just going to redraw these lines. Okay, so here's A. All right, I drew a line from the center to A. This is line 1, this is line 2. I'm going to reflect over line 1 first, okay? So what am I going to make the distance between line 1 and A equal to? X. Okay, you could have done any letter, all right? The issue is when I reflect it across, so I move this across, it has to be the same. See how there's an X on this side? I better make sure there's an X, and this is A prime on this side. So far, so good? Okay, A to line 2 has to be a difference. It can't be X, so I'm going to make it Y. Now, see everything on this side of line 2? That Y, X, X? I have to make it on the other side. Y, X, X. and that's A double prime. Then the distance between line 1 and line 2 is right here, x plus y. And then the distance between A to A double prime is all of that. Okay, so x plus y and 2x plus 2y. And it should be twice the difference. Any others that you want me to go over? A compass, a mirror, a patty paper. One of the ones where you have to fill out the whole thing. Yes, Madison? The second translation? Okay, so we know that whatever it does to x goes right or left, right? It's x minus 2, so each of these has to go 1, 2 back. Okay? And then it is 1 up. So this has to go 1 up. So each of these has to go 1, 2 to the left, 1 up. 1, 2 to the left, 1 up. So that's your new one. Right there. Yes? You have a question, Kayla? Yep. So it says reflect across the y-axis. This is the y-axis right here. Okay? So it's just across there. So this is 1 away from that orange line. It's 1 away on the other side. This is 1, 2, 3, 4. So it's 1, 2, 3, 4 on the other side. This is 4 on this side. That's your new. Others? Okay, remember you can watch murphymath.com again to try this again. I also have these up there, blank versions of these, so you could print this off if you wanted to and try it again. But we're taking this tomorrow, and it is 40% of your exam grade.